Okay, and welcome to this presentation about the truth about climate change and discussing if it is really so simple. Listen to the expert, climate scientist. That's all, what they say. I agree. We should be listening to scientists, the people, the experts in the field, the ones that have been looking into this for decades, right? Not politicians, TV presenters that keep pushing the same narrative. Scientists are the ones that are seeking for truth and leave no stone unturned and are willing to question their own position and hypothesis. They absolutely prioritize the truth over and above their feelings and own interests. That's what it's all about, and that's what spirituality and philosophy is all about as well, and that's what I'm all about as well here on this channel, Freedom Philosophy. And it's not about popularity, it's not about consensus, it's not about feelings, and it's not about politics. Just because somebody is unpopular or comes out with an unpopular proposition doesn't make it wrong. The truth is all about unbiased rationality and facts, right? Reality is not decided on the basis of morality or personality or emotions like fear. It's the same with religion too, and spiritual philosophy, and reality is not based on what you personally think it is. It is based on what reality is. Reality is what is. That's the simple fact of the matter, right? Over 31,000 scientists in America alone. So this is a national petition that have signed this statement rejecting any climate alarmism to say that there is no convincing scientific evidence that human release of carbon dioxide, methane or any other greenhouse gases is causing or ever will in the foreseeable future cause catastrophic heating of the atmosphere and disrupt the Earth's climate.
Let's look then at what CO2 has in common with temperature. Here's where, this is about 1945, this is where the emissions began to rise sharply, and we have 30 years of global cooling. And before that, from 1915 to 1945, we had global warming without any increase in CO2. So who needs CO2? And it gets even more than that. In this graph, I plotted temperatures from isotopic evidence in ice cores. The red peaks are periods of global warming. And there are 20 on this graph dating back to about 1500. If you go back even farther, if you go back 10,000 years, this is 10,000 years ago, this is the present, temperatures are about 2.5 to 5 degrees warmer than present in Greenland. No CO2. And then about 1,500 years ago, we've dropped into what has become the Little Ice Age. Going back even farther, 25, 30 years, 1,000 years, we have the last Ice Age with huge warming of 20 degrees in less than a century and dropping of temperature of 20 degrees in perhaps around a century and rising of temperature about 20 degrees in a century, all without the benefit of CO2.
Well, right now, the sea level at Sydney is about 6 centimetres lower than it was in 1914. Now, sea levels are affected by, on a day-to-day basis, by the moon rotating around the Earth. And in the long term, the small pluses and minuses in mean sea level is affected by the planets moving round the sun in elliptical orbits, and sometimes they're closer to the Earth than they are at other times.
We are here at zero in the Neogene. Go back a 500 million years. And the first thing you see is that it is about as cold right now as it has ever been in the last 500 million years. We are actually in an extraordinarily cold period. We are in an ice age today. We're in a relatively warm period of an extremely cold period. But average for Earth is a lot hotter than it is today. But what you should take away from this slide is there's nothing normal about climate. Climate varies a lot. And what he found was that if you look at these cycles, that the orbit of the Earth's orbit actually affects the amount of sunlight you get tremendously, because there's an eccentricity cycle that goes from about 0 to 6 degrees in the roundness of the orbit. There's a tilt cycle that goes from about 24 to 21.5 degrees. And it turns out that just lines up with the relative cold and hot in the climate. This is more of the data that I took. And so there's the 100,000 year, this is hot, this is cold, this is right now, this is roughly 100,000 years ago. That's the previous interglacial. This is the eccentricity cycle, 100,000 years. There's the precession cycle, 23,000 years. That's the tilt cycle, 41,000 years. It lines up. These orbital changes absolutely dominated our climate for the last 500,000 years.
If you look at this graph, when it's in a book, that's about 4 inches of graph that's covering 420,000 years. They said this is proof that the temperature is driving, or CO2 is driving temperature. We knew within 5 years that it showed exactly the opposite. That the temperature changes before the CO2 changes. But what's the whole fundamental assumption that they make? They say, oh, CO2 goes up, the temperature will go up. So the fundamental assumption they make about CO2 and temperature is wrong. What this shows is the current level, CO2 is the red line. And here we are at the current level, 400 parts per million of CO2 in the atmosphere. And Al Gore tells you that's the highest level we've ever had. Look at this graph. It is in fact the lowest level we've ever had. Okay? And in fact, you could argue, looking at here, the last 300 million years, that the CO2 level has averaged around 1,000 to 1,200 parts per million. 3 times what we've currently got. And do you know how we know that's important to the Earth? Because if you go to the greenhouses on the coast here, the commercial greenhouses, they pump up to 1,200 parts per million of CO2 to get the plants to grow more vigorously. In fact, you could, and Dr. Idso has done 30 years of research showing that increased CO2 increases the yield of the plant. And also, by the way, reduces the amount of water it uses. So I think that that's 300 million years of evolution of plants to an optimum level of about 1,200 parts per million. So you could argue, say, the plants are malnourished at 400 parts per million.
There's very little evidence that humans are making much impact. And as far as CO2 is concerned, which is the major focus, that's probably more good than bad. Well, you know, I know a lot about CO2 compared to most climate scientists because we make CO2 lasers, you know, and CO2 is a very interesting molecule. And the particular mode of CO2 that contributes to global warming, CO2 is a rod and it bends like this, up and down, up and down. And it's that bending motion that causes global warming. But that is such a strong absorption that it's saturated now. So as you add more CO2, most of what you can do has already been done. There's still a little addition, but not very much. There's an interesting thing about CO2, which is unique to CO2. It's not true, for example, of water vapor or methane, and that is that if you get 1 degree of warming from doubling CO2, so going from, say, 400 parts per million for simplicity to 800, that doubles it. Mm-hmm. Suppose that causes 1 degree of warming. Then to get another degree of warming, you have to double 800, so you have to go to 1600. So you have to double it again. So it gets harder and harder to warm. technically they call that the logarithmic dependence.
During the 1990s, the rate of fossil fuel emission increased almost linearly, growing each year by 0.08 gigatons of carbon per year. Were it retained in the atmosphere, that growth of emission would be equivalent to an annual increase in the growth of atmospheric CO2 of 0.04 parts per million by volume, ppmv, per year. After 2002, fossil fuel emission also increased linearly, but 3 times faster. By the end of the period, fossil fuel emission was almost twice as great. During the same period, CO2 increased linearly, especially after 1995, when it increased at about 2 ppmv per year. After 2002, CO2 also increased linearly, but at exactly the same rate. The growth of fossil fuel emission increased by a factor of 300%. The growth of CO2 didn't blink. This is an estimate of the CO2 budget by the IPCC itself. It's the checkbook of CO2, the financial ledger that determines its balance in the atmosphere. The human source is of order 5 gigatons per year. The rest involves natural sources and sinks. They are larger by 2 orders of magnitude. Of total emission, natural emission accounts for over 95%. Net emission is the balance of these entries in the CO2 checkbook. For it to be dominated by the anthropogenic component, natural emission and absorption would have to remain perfectly in balance. Even a minor imbalance would overshadow human emission. Of those dominant contributions to the CO2 budget, our knowledge is limited. Observations of natural sources and sinks are scarce. Their collective impact, however, is unambiguous. In the atmosphere, CO2 is conserved. Once introduced from the Earth's surface, it's neither produced nor destroyed. It's only rearranged by the atmospheric circulation. The rate of increase of atmospheric CO2, its growth rate, must therefore equal its rate of net emission from the Earth's surface. Embodied in this equation is the budget of atmospheric CO2, which determines its abundance. Net emission is just the sum of emission by all sources, minus the sum of removal or absorption by all sinks. Among the sources is human emission. Everything else is natural. By the IPCC's own estimate, the human contribution is small. The rest, from natural sources and sinks, represents more than 95% of what determines atmospheric CO2. Net emission is a resultant of all contributions. It must equal the instantaneous growth rate of CO2. That property is derivable from the observed record of CO2. In green is net global emission of CO2 from all sources and sinks. Does net emission resemble the human contribution? Not really. The observed evolution of net emission bears no resemblance to its contribution from fossil fuel emission. In fact, the two records are incoherent. Net global emission evolves independently of the human contribution. Okay, Is the discrepancy from fossil fuel emission small? Not really. Observed changes of net emission are huge, as large as 100%, as they are absent in the contribution from fossil fuel emission. Those changes of net emission can follow only from what remains, changes of natural emission. If net emission does not resemble human emission, what does it resemble? A clue comes from the evolution of CO2 during the last 2 decades. The growth of fossil fuel emission increased sharply by 300%. The growth of CO2, which follows from all contributions, remained constant. During this period, one other property also remained constant. Since 1997, global temperature has varied little. Except for weak cooling, it remained constant. Unlike observations of CO2, observations of its emission are scarce. All we have are local field measurements. They are few and far between. Nevertheless, those local observations reveal that CO2 emission is sensitive to surface properties of land as well as ocean. In contrast, anthropogenic emission is independent of surface properties. The sensitivity of emission observed locally is confirmed in the evolution of global CO2. In blue is the component of net global emission that operates dependently with surface properties. It tracks the observed evolution of net emission. The blue curve represents changes of CO2 emission that are induced by changes of surface properties. Achieving a correlation of 0.93, the induced component accounts for nearly all of the history of net global emission. The surface properties on which national emission depends are diverse, but one carries the lion's share. Temperature by itself achieves a correlation to the observed record of 0.8. It drives the thermally induced contribution to CO2 emission. As we've seen, net CO2 emission depends strongly on temperature. This makes CO2 dependent on temperature. That dependence is measured by the cross-correlation with temperature, not of CO2 emission, but of CO2 itself. Plotted here is the cross-correlation between CO2 and temperature as a function of lag between those properties. It measures how large of a change in CO2 results from a change in temperature, along with the relative timing of those changes. Their cross-correlation is significant across a wide range of positive lag, where changes of CO2 follow changes of temperature. An increase of temperature is followed 10 months later by an increase of CO2. Hence, like emission, CO2 is strongly dependent on temperature. Its lag behind temperature leaves unambiguous which is the horse and which is the cart. This leaves global temperature to be controlled by just about everything but fossil fuel emission.
So where are we? Misrepresentation, exaggeration, cherry picking, or outright lying pretty much covers all the evidence. So we reach a conclusion. There you have it. I mean, an implausible conjecture
backed by false evidence, or less kindly, fake news, and repeated incessantly, has become politically correct knowledge. And it is being used to promote the overturn of industrial civilization. False claims about 90%, 97% agreement will not spare us, but the willingness of science to keep mum is likely to much reduce trust and support for science. And perhaps this won't be such a bad thing after all, certainly as concerns official science. There's at least one positive aspect to the present situation. None of the proposed policies will have much impact on greenhouse gases. Thus, we will continue to benefit from the one thing that can clearly be attributed to elevated carbon dioxide, that is, namely, its effective role as a plant fertilizer and a reducer of the drought vulnerability of plants. Meanwhile, today, the IPCC is claiming that we need to prevent another 0.5 degree centigrade of warming, since the 1 degree centigrade that has occurred so far has been accompanied by the greatest increase in human welfare in history. As we used to say in my childhood home of the Bronx, go figure.
There you go. Anyway, thank you very much for watching this. Be happy. Don't panic.